video, we're going to be factoring a quadratic trinomial when the lead term, or a, equals 1. Here we have what's called a quadratic second degree trinomial, 3 terms. And we're going to be focusing in this lesson on when that lead term seems to be missing or there's a 1 there. Makes it a little bit easier, actually. So the general concept is going to come from undoing something that you did in a previous lesson. I like to think of this kind of factoring as unfoiling. Remember, when we foil, let's focus back up there on that quadratic trinomial. We do firsts, outsides and insides, which usually will combine, and then we multiply our last terms. And when we multiply 2 binomials using the FOIL method, we get, generally, a quadratic trinomial. So for us, those first terms are going to be super easy in this lesson because there's only one way to multiply and get x squared, and that's if we have x times x. So it's going to be those last terms that are going to be our challenge. So here's a quadratic trinomial. Again, those first terms, no worries with those. It's the last term. So we're going to go focus on that very last term, that 15. And we're going to ask ourselves, what multiplies to equal 15? And there's 2 options. The reason I've color-coded the 3 and the 5 differently is because that's going to be our winner. Because remember, the O and the I need to add up to that middle term, or that 8. And 3 and 5 add up to 8. So when we unfoil this quadratic trinomial, we will have our first terms of x and x has to be in this lesson. And then our last terms we have to multiply to equal 15 and add up to 8. So positive 3 and positive 5 were our winners. We can always check this by foiling. Let's give it a try. Firsts, x times x gives us x squared. Outsides, plus 5x. Insides, plus 3x. And those add up to 8x. And lasts, we have 3 times 5, which is positive 15. So when we unfoiled it, we could check it by foiling. Turn the page here and take a look at 4 quadratic trinomials. They all look pretty similar. And you should maybe pause this video and write them down. They all have that lead term, or that a of 1, because we don't see anything in front of that x squared. They're all ending in a 30, either positive or negative. So remember, we focus on that last term and we think, what multiplies to equal 30? We have a lot of options for that one. For each one of these, we're going to say, what multiplies to equal 30? What multiplies to equal 30? What multiplies to equal 30? So we have 4 different pairings of numbers that multiply to equal 30. Remember, it's this middle term with its sign that is going to help us conclude which pair to use. So after focusing on that last term to get our candidates or our possibilities, we use the middle term to decide which pair wins. So we see this positive 11 and a positive 30. So to multiply, we're going to have the same signs. And in particular, we're going to have 2 positives because we need to add up to a positive 11. So my winning pair is that bottom with a positive 5 and a positive 6, because those 2 numbers, or that pairing, multiplies to equal to 30 and adds up to the positive 11. On the next one, we still need to multiply to equal a positive 30, but we need to add up to a negative 13. Well, again, to multiply to equal a positive, 2 numbers have to have the same signs. However, they can't both be positive because 3 plus 10 is positive 13. So I need them both to be negative. And then when I check that, I ask myself 2 questions. Is my pair multiplying to equal the last term? Negative times a negative will give me a positive. 3 times 10 is 30, so that checks out. is my winning pair adding up to the middle term? And mine do add up to negative 13. So on this third one, again, we have that 13, but 3 and 10 aren't our winner because we need to multiply to equal a negative 30. So we can't have a 3 and a 10, as those make positive 30, or a negative 3 and a negative 10, because those also multiply to equal positive 30. But when I look at this 2 and this 15, I think to myself, I can get a 13 out of those as long as one of them's negative. So I have to decide on their signs. The sign of the middle term goes with the larger number because we need to add up and have more positives or balance out to be positive. So I have to have positive 15 and a negative 2. Again, I check that. Do they multiply to equal the last term? Yes. Do they add up to the middle term? Negative 2 plus positive 15 is 13. Now on this last one, we didn't see a number in front of that x, but remember there's a 1. So we need our two numbers to multiply to equal a negative, which means I need a positive and a negative, and they have to add up to negative 1. So I have the same pairing as in the first one, but the first one I had to add up to 11. Now I need to add up to a negative 1. So again, the sign of that middle term goes with the bigger in the pair because we need to balance out to be negative, and again, check them. 5 times negative 6 is negative 30, gives me that last term. And when I add them up, I get the middle term. So let's go back and repeat about these signs. When they're both positive, both my factors will be positive. When I end in a positive, but the middle term's negative, it means I need to have either two positives or two negatives, but to add up to a negative, I'll need two negatives. A negative times a negative is a positive. Negative plus a negative is a negative. Now on this third one, I knew I needed to have one of each sign because I have to multiply to equal a negative. And then the sign of the larger one, the sign goes with the larger number. Same in the last one. So let those signs help you to wrap up those pairings. So here's our 4 factored versions of those 4 quadratic trinomials where we found a pair of numbers that multiplied to equal the last term and added up to the middle. And again, we can always check it by foiling.